Start recording. And here we go. So today we are going to talk about programs. Before we talk about programs, though, let's just have a discussion. Where in the world around us do we see computer programs being used? Feel free to unmute and shout out your answer, or just type it in the chat.
Where don't we?
Good question. But let's come up with some specific examples. I'm sure that we can think of some specific examples.
Video games?
Video games, absolutely. In a computer, sure.
When we use Zoom.
When we use Zoom, absolutely.
In a calculator?
Calculators, yep. Where else?
Web pages?
Web pages, absolutely. All right, everyone's here. All right, where else do we see computer programs being used? Printers, absolutely. So, all right, that seems like a good smattering of different places for everyone. So, as you can probably tell by our varying responses, we use computer programs just about everywhere. They are nigh upon essential for life as we know it to operate as it currently does. Computer programs are everywhere in our current society. So let's discuss what programs do at a very basic level. They implement algorithms, and an algorithm is a self-contained, step-by-step set of instructions that is used to solve some problem. So let's think of some ideas of things that qualify as an algorithm. So as an example, a recipe, when you're making some sort of food, counts as an algorithm because it's self-contained. You start with nothing, you start with ingredients, and you end with some meal or dish or something. And it includes step-by-step instructions to follow to create that meal or dish. So what else can we think of that fulfills those kind of requirements? I'll go back to our definition. What kinds of things fit that definition?
An instruction manual to put together a piece of furniture or something?
Absolutely. Instructions for furniture. A cooking recipe, absolutely. What else counts as an algorithm?
Solving Rubik's Cubes.
Solving a Rubik's Cube. Each step of solving a Rubik's Cube, you have a specific set of instructions, and that you get to the next step, solve another piece. Exactly. Is a flowchart an algorithm? I think you could probably qualify a flowchart as an algorithm. You have step-by-step instructions. Sure. Sheet music, absolutely. There is a step-by-step instruction that you follow to create some sort of a product.
Math?
Math, definitely. You do step-by-step instructions and you do math. Would following like Google Maps directions be an algorithm? Absolutely, because you are starting somewhere, your goal is to get somewhere else, and you have step-by-step instructions on how to actually perform that navigation. So there's all kinds of different algorithms all over the place. As an example, the hokey pokey, which I'm sure some of us might be familiar with. The hokey pokey dance, you put your right hand in, you put your right hand out, you put your right hand in, and you shake it all about. that is an algorithm. It's not particularly useful, but you're following a set of instructions to do a dance. So that is also an algorithm. So like I said before, programs are the thing that implements an algorithm. And implement is just saying that it's taking those step-by-step instructions and telling the computer how to actually execute those steps. So computer programs implement algorithms for the computer, but with the hokey pokey, I could implement that algorithm by actually doing the dance, doing the hokey pokey. Or I could implement the instructions of building a piece of furniture from IKEA by actually following the directions, building the IKEA furniture. Does that make sense? How cool? Yeah, okay. So there's computer algorithms for absolutely everything. There's algorithms to sort the songs you have in your music library, for suggesting videos to you on YouTube, for finding the best result for your question in a search engine, for facial or speech recognition, for playing some video on your computer screen, for sending audio to the speakers of your computer. There are algorithms for basically anything that your computer can do. There's a set of step-by-step instructions to actually accomplish that goal. And a lot of the time when we are building programs, we reuse existing algorithms when we are creating our own new ones. And the reason we reuse already existing ones is because it helps. Using ones that we already know work helps us to make sure that the new one will be correct. If all of the building blocks we're building with work well, then the entire structure should work well as well. If our building blocks aren't good, then our project is destined to fail from the get-go. So we want to make sure that all of our pieces that we're using to build our programs work well as well. Different programs are developed for different reasons. They're developed and used in a variety of different ways, depending on the goals of the person writing the program. So a program that is developed and intended only for use by the programmer is going to be developed very, very differently from a program developed for use by a large number of people. If you're developing for a large audience, you might have to include error handling and protection against malicious attacks and things like that, where if you're writing code only for yourself, you really only have to worry about your own inputs, your own outputs. So the development cycle will be very different for the two different types of programming projects. There are lots of different reasons that people choose to write computer programs. Here's some common reasons why they do so. People write programs to express their creativity. They make art or music, or they create a video game that will express their creativity. To satisfy personal curiosity, you can write computer programs to test your own skill and abilities, or to learn some new skill. Let's say you wanted to learn how to build a website. You could learn how to do that and satisfy your own curiosity on how to build websites. People build programs to create new knowledge. They write programs to process data, to make understandings of the world around us. And another very common reason is to satisfy needs that are seen in the world around us. Google, Amazon, Netflix, these all have developed a software product that fills a need that exists in the world. Google's filling the need of people to find different things on the internet. Amazon fills the need of people wanting to buy things on the internet. Netflix used to provide DVDs on loan, but now they stream video for everyone on the internet. So they fulfill that entertainment requirement. So when a need is seen, people will often generate software or a program to fill that need. And computer programs or the results of running a computer program can often be shared to huge numbers of users, especially given the digital age that we live in today. And this can have massive impacts on individuals, on organizations, on society. So as an example, Tesla, the electric car company, spent a long time working on research and development for software for their cars that will allow them to drive themselves, doing all of the sensor readings and figuring out how to actually do all of that automatic driving. And one day, they just decided to, when they had finished with all of that development, they pushed an update, a software update to every single Tesla vehicle. And the day after that, every single Tesla vehicle was able to do autopilot. So this single area of development was made available via the internet, via software for lots and lots of people to interface with. And programs and advances in computing have absolutely influenced other fields like music or science. They change the way that those fields are done today. With music, we can remix music, we can do digital editing, we can make electronic music, which couldn't exist before. We can share music with each other digitally. In science, we can collect data, we can analyze data, we can do better calculations than ever before due to all of the advances in our technology, in our software, and our hardware that we've built over the course of our human existence. As I'm sure you're all aware, you can find computers just about everywhere. You're all on a computer right now, listening to me talk. So modern computing devices like desktops, laptops, and tablets, those are everywhere in our society. And we as computer scientists are able to create programs that will run on basically any one of them, because they are fairly open systems where we can create programs that will run there. But there are computers everywhere. There's computers and smartphones and smartwatches. Different toys and cars and appliances all have software and programs that run on them. So not all of these kinds of things are able to be developed for. I can't make a program to run on my microwave, for example, but it does have software that it is running. It has programs that it does by default. So even if I'm not able to write a program for some of these different devices, they are running programs themselves. Some various applications of computers. We can use them for autopilot in planes and cars. We can use them in medical devices. Defibrillators and pacemakers are things that really couldn't exist without software, especially pacemakers, making sure that people's hearts continue to operate correctly. Software is used to make art. This piece of art, it's possible that it could have been made before computers, but it would have been very, very difficult. With the advent of software that is used for art, this became much easier to create. Software is used for making music. You can splice together all kinds of different music pieces. You can do remixes, you can add effects, you can do whatever you want. Software is used to improve agriculture. You can see different like heat maps to see where is the best place to plant a crop. Where am I going to get the best yields, things like that. Software is used to help people in health and medicine. Software is used to help blind people to actually see at some level. Like I said, with defibrillators and pacemakers, all of those things are controlled by software. And you can also use software and programs to analyze where we see illnesses popping up and try and figure out how to best contain those sorts of things. So it's helping us with illness prevention. And lastly, software allows us to communicate. And I know all of you are on Facebook still. No one uses Facebook except for old people. But Facebook and messaging and news apps, or Snapchat or Instagram, any of these social media platforms are used to communicate with each other, and they're all built using software, using programs. So programs are vastly applicable in the world around us. So yeah, any questions about programs as a whole? We'll actually learn how to start writing programs next class, or we'll review if you've already learned how to write programs before. We're going to do actual programming next class, but giving an overview of what programs are, where they're useful, and why. Pretty cool. All right, so the assignments for today are within the Programming in Python module on CodeHS. We are in module 3.2, uses of programs. So there's a video to watch called Why Should You Learn to Program? It's a TED Talk. And then there's a few just free response answer places for you to answer. So you can spend the rest of our class time working on those things. And there we go. Stop my share and stop recording.